Good. So welcome to the Software Developers Thursday. As you probably know, every month, every first Thursday in the month, more or less first, and it depends on the date, but usually the first Thursday in the month we organize a meeting here where we invite software developers mainly to share information about the technology they are using in their projects or they are passionate about. And after the presentation, we have a catering where people can talk to each other and get to network. And that's the main part. So the main part is that you get to know other people from other organizations, and maybe in your case you are students of the Faculty of Engineering of the Free University of Bolzano, and you probably maybe have to do your internship. So maybe you will find some companies and some organizations you can apply for an internship. Could be an opportunity. Why do we organize these meetings? So we as Neue Tech Park want to help the inventors, the developers, the companies, the startups here in South Tyrol to create new innovation. And mainly we help them do projects in three today I'm not good at talking in three specialization areas, we call them. So the first specialization area is Internet of Things. So it's about data collection. So we collect data from our nature or from buildings, smart energy management in districts, for example. Then we have the specialization area Open Data Hub, which is data management. Through our project Open Data Hub, we help organizations share their data, and also startups can then use this data more easily. And you will show us today some nice research projects done on top of the Open Data Hub. And once we have the data, we can expose this data and use it for useful things. So we call this data processing, also artificial intelligence, because once you have the data, you can use it in applications and also in more vertical artificial intelligence applications. For example, you can implement as a region a mobility as a service strategy. You need real data to do that, and the real data comes from the IoT, from the sensors. This is the idea, and all the actors in Neue Tech Park help us implement this data pipeline. And today we have Eduardo Guerra. Thank you for joining us, and thank you for working together with us as Free University of Bolzano. It's very important for us to have this collaboration to get you on board, and we will see your projects. So I'm looking forward to it, and after your presentations we will have a discussion round. Today I assume we will do it as the poster, so we can discuss your projects, and afterwards I have some slides about the next events we will organize at Neue Tech Park. But before we go to that slides, I hand over to Eduardo so we can see the projects.
Thank you very much. So today I'm here just as a host also, because the idea on today is to take a look on some of the students' projects. Okay. Okay, so this is in the context of the software architecture course in the Master in Software Engineering. And this year was the first year that we have, as part of this course, the topic of agentic architectures. Right, so in these partnerships between the university and the Open Data Hub, the idea is that the students did a project where they're going to get some data from the Open Data Hub and also use an LLM to do some kind of processing of this data, right? So I briefly see some of the project's themes. They seem very interesting. I'm really looking forward to see. So the format we are going to do is the following. I concatenated the slides from all groups. We have 7 different groups here. The order that I choose was completely random. So this is the first group. Bryce? Okay, so once you finish your presentation, you can already come. So once you finish your presentation, you move to the next slide. It will be already the next group, so you just come here and continue the presentation. Okay, deal? So in the end, we have the slides, but each group also have their computer with their solution running. So you can also have maybe some more detail or concrete view after the presentations. Okay, so the idea is to make a quick, let's say, pitch or to show what the project's about, but then you can actually see more details in the poster session. Okay, so thanks for being the first one, and the word is with you.
Thank you very much. Hello, everyone. My name is Brice Taton. Well, some of us have never seen me before because I'm a non-attendee. So I'm watching recordings of courses and also talking a lot with professors just to keep in touch and keep aligned with courses. So, hello. Well, my project, well, I'm saying my project simply because unfortunately, I had to work on it alone as a non-attendee. It's okay? Yes. Okay. So the project is about the mobility in cities. Since we have all this data available in the data hub, we focus on mobility, so transport and different type of facilities. We decided to build a software that can actually help citizens to use in more sustainable way the mobility facilities. So the problems we identified before talking about the project are the followings. Traffic congestions. The congestions in a city is one of the problems that we have the community needs to face. And we noticed that the traffic congestions was really increasing. This is also because some of citizens decide to use their personal car. That is not sustainable, maybe. And other motives is because of the eco-mobility services that are available in the city are not really used. And the other one is about the real-time guidance. There are a lot of applications today that are available for citizens that can facilitate their mobility, but they are not really used. So to these problems, we found different solutions. Using the data available in the data open data hub. The uh, first one is about the suggestion of an eco-friendly routes. So if we could make available to the user an instruction that is human readable, that can easily facilitate the mobility of different citizens in the city. Another one is a recommendable e-bikes and scooters in our cities. There are a lot of facilities like that, but they are not really, let's just say, available to the user or to a certain type of user. Maybe they are used to an application, or they are used to see posters. So if we could find a way to make available these informations based on the data in the cities to them, it will be easy for them to use those facilities. So our solution is first of all based on the LLM and the use of the data in the Open Data Hub. This is the workflow we decided to implement. So the user can digit any, let's just say any type of request. It can be for asking information about the mobility. It can be general information about the real-time data in a certain location. So in our solution, we have 3 models. The first one is the context validator, because we need to understand if the user is actually asking something that we support, that the application can handle, can process, and give some information. The second one is the intent classificator, because we support general information. We also support real-time data. So we need to classify to know how to handle. And then the third one is the reasoning LLM. He is the one in charge to fetch, to work with the data from Open Data Hub, and then produce a sentence or a set of informations that is human readable. And we also thought about the provider of these data. The solutions that came up is an MCP. Why an MCP? First of all, we needed a way to make this extendable in the future, because for the moment we have different type of facilities available. We have cars, we have e-bikes, we also have, we don't have scooters. So we needed to make it future-proof, so that in the near future, if you want, we can easily add another type of facilities, like public transport or scooters. So, thinking about future-proof, we also, the way we found easy to implement this, so that we can guarantee that in the future it will be easier for us to add or modify other modules. We think about the clean architecture, support with a service-oriented architecture. So we have different modules. The application user interface modules that can actually support different type of framework, front-end frameworks. We also have the core modules. The core modules is where we implement all the logic of the LLMs. And we have the infrastructure where we implemented the MCP client actually that communicate with the MCP server to fetch the data. So here is the MCP server part. This is also a clean architecture because we needed to separate the client that talked with the API and the logic that will handle that data, the data that we fetch from the open data. And here the core is particular is because we need to think about the MCP pattern. So each service can actually represent a tool that will be made available to the client MCP. So the benefit of our architecture is that in the near future we can extend. We can actually it's actually future ready because we can add some modules that we have maybe communicate with different users. This means that it can actually be integrated in another application, modifying only a specific part of the system. It is also scalable because in an LCP server we have different type of transport. The transport, so the SSE transport, which is server, that use the HTTP communication. So the server runs in his own environment, so it can actually scale independently. So the result of our work till today is, let's just say, can be considered an 18% because let's just say that I try to do something.
Sorry to interrupt, but if we go like this, we don't finish. So,
Okay,
you already go over the time a lot. So if you want to see more details, then you can ask in the post.
Okay.
So thank you very much.
Thank you.
So.
Okay. Thank you very much. Thank you. Thank you.
And the next group. It was just 5 minutes. You did almost the job.
Perfect. We probably don't have a presenter, right? So I need to use those buttons. Okay. Good evening, everyone. I'm Andre. Okay, we have an application which is called Pass to Hike. So I'm Andre. Andre in English, please call me Andrew. In Italiano, you can call me Andrea. And those two people standing next to me are Antonia and Alessandro. And besides Eduardo, where we have Eduardo here, and besides Marco, they were the very first people I met here at UniBZ. And then, please, next slide. Okay, so we quickly found out that we all love hiking. And because we also care about environment, we usually get to those hikes by bus. So we decided to connect those two things together and create an application which is called Bus to Hike. Okay, and then I will...
Thank you.
Okay.
So next slide. So we all probably know the problem when you search for a nice hike, but you cannot get there because we don't have a car. So then we have to dismiss this special hike. So we wanted to turn this whole approach around and actually search for the bus station first, or whatever transportation stop, and then look for hikes according to different filters. We, for example, have the length of the hike, the difficulty, and the duration. And if you get on the hike and off the hike at the same location. And then we search for hikes around this special location of the bus stop, and then we get hikes that we can go on. Furthermore, we also have the dynamically generated trails. We will hear more about that later, and difficulty estimation of the hikes. Thank you.
Okay, so we did two different implementation of the application. The first one, we gathered the data of the hiking trails and the transportation data of the stops from Open Data Hub. The hiking trails were missing of the altitude information, so we gathered that data from Open Elevation, that is another Open API, and then we used the PG routing library. This is a Postgres SQL library, to build a trail network to actually generate the dynamic trails, because the problem was that Open Data Hub doesn't account for the intersection between trails, so and some trails were scattered. So to actually create dynamic trails, we have to kind of rebuild the data, the data set that was behind it. Yeah, we got dynamic trails. So thank you all.
Good evening, everybody. I have the pleasure to introduce our project, Wildfire Warning System. In recent years, forest fires have become an increasingly real threat, partly due to climate change, and their impact and violence are set to grow. It's enough to say that in 2025 alone, accordingly to data published by Autonomous Province Forestry Service, more than 231 hectares of forests were destroyed. More than double the highest figure recorded since data collection began in 1977. It's clear, therefore, why every form of prevention and early detection should be encouraged. Oh, yeah, I forgot to change the slide, sorry. According to National Law 353/2000, a forest fire is defined as a fire likely to spread to wooded areas or to adjacent non-wooded land, such as pastures, also above the tree lines. The system aims to help understand the probability of a fire breaking out, and by refining the metrics in the next future, hopefully try to determine the risk of surrounding areas to avoid its proliferation. The aim is to protect not only wildlife and environment, but also economic means of communities. Thanks. As a solution, we envision a system based on environmental data and AI-based risk assessment. We assume that users can be both professionals and mountain and hiking enthusiasts. For this reason, we designed also a basic graphical interface that will represent South Tyrol and visually display the points where environmental data are available.
I apologize in advance because I have really problem talking in front of people, so sorry if I don't look at you. First, environmental data is retrieved from Open Data Hub and stored in our system database. This data already exists in database and is continuously available. The AI model reads data from database and analyzes it using predefined rules. Based on this analysis, the system estimates the probability of a fire occurrence. The analysis results are displayed on an interactive dashboard. Users can select a specific location on the map, and the system shows the corresponding fire risk level. Risk levels are classified as low, medium, high, and critical, making the results easy to understand. The fire risk estimation is mainly based on, actually it's 4 parameters: temperature, wind speed, rainfall, and also weather code. Changes in these factors directly affect the final risk level produced by the AI model. All environmental data used in the system comes from Open Data Hub, which provides reliable regional environmental data. Thank you.
So hello. Currently, we only have like a web dashboard. It's like an interactive dashboard. You can go and click the location or some cities. Then you can see what is the probability of the fire. So our expected impact is like a fast response and also the reduced property damage and environmental loss, and also the protection of communities and also the natural resources. So currently we only have a web dashboard, so user have to go our website and check where is the fire is happening, something like that. But we personally think it's not like a practical approach to solve this problem. So our future work is like creating assessment alert service, like it's getting the live firing data, and also it analyzed using the AI and sending to the users if there is something happening. It's going lively notification to the users using SMS alerting service. So, okay, thank you very much.
Hello everyone, myself Mohammad Salman, and our project is totally based on tourism. So we use Open Data Hub because it used to structure all the data, because when we talk about tourism, everyone wants everything in a structured way. So we use React for the front end, and for the back end we use Node.js, and for the summary of the all website we use LLM.
Hello, good evening. So I'll talk about why we need this project, because on Data Hub we have seen that there was a lot of data which provides a rich tourism data sets which we can't handle in a way that if a user is non-technical, so they can use this data set to gather some useful information. So user always needs clear insights, not raw JSON. So what is our project? Basically, it is a web-based tourism data exploration tool which display tourism destinations such as cards, and there are some different categories. Like in the data set, we have seen that there are different regions across South Tyrol, like Bolzano, Brixen, Sturzing, and all that regions are, they have different point of interest, like they have certain cafe points, and then if we talk about other categories like hiking points and all that stuff, so they are shattered in the data set in a different way. So we are having some functionalities which will be displaying tourism destinations as cards, categories, and then there'll be some regions. It focused on data understanding, not booking. Like when we gather data for the tourism, people are always curious that we can have a booking or we can have some certain functionalities with that. But it is to focus on data understanding. How we will understand data here? We have used data sets which will provide tourism points of interest. Then I have discussed these things. And then the location metadata is also there in the data sets. What is the system architecture? We have front end, then Java Spring Boot backend, then an Open Data Hub Tourism API. What is the backend responsibilities? It fetches point of interest, then aggregate data and expose REST endpoints. So that is the system architecture. What is the design choices and trade-offs? It is a Java-based backend with RESTful architecture, and it have a simple aggregation logic. What is the trade-offs? It simply just summarize the data. It is not there to have you it is not. It doesn't have a functionality which is for booking or pricing, and there is no predictive AI. Like we are using LLM to summarize the data we are providing. It's not like that. It predicts some information across the other regions. So it is specific to the data provided. And then what is the role of LLM? It converts numerical results into text summaries. Then it improves data interpretability. For example, if we give a certain data set to it, it will have a summary by using LLM that the data set contains 29 destinations with a strong focus on nature and adventure tourism. So that's all. The results are will show you there that what are the results we have come across. So thank you so much.
Hello, good evening. My name is Jeffrey, and together with my teammates Kwan and Miriam, we're representing on Portable Mama, which is like a mobile application. So I think we've all been there when like you're halfway through the door and then you hear like a familiar voice and it tells you like, oh, don't forget your umbrella, don't forget to take your jacket. Yeah, so moms are like really essentially like the world's first real-time notification systems. So this is exactly what inspired this project, and it's a mobile application. So it's like a location-aware system that knows where you are and then also predicts information to you, because surprises are better when you are ready for them. Okay. So the application also includes weather alert. So instead of just giving you numbers, the AI it makes meaning out of those numbers. So it tells you like what to do, what not to do, and then like how to prepare for the weather, currently the weather situation. So that's what the weather alerts do. And then for our outdoor lovers, it also comes with like a ski feature. So depending on your location, it suggests like skiing areas around you that you can go and then ski. And on top of the skiing information, there's like real-time alerts for ski conditions. So it gives you alerts on like what safety skiing gear to take to the particular skiing event. And also it has like a traffic system, so it helps you plan ahead and to avoid congestion. So because you have the information ahead, you are able to know which routes to avoid and which routes to take. So there's also like a navigation system in the application as well. And then finally, we would like to show you like a screenshot of the application. So there's like a dashboard of the application where you can see the weather information presented in like a nice UI experience. And there's like the ski areas, and you can actually see the LLM in action. So there's like an AI tip which predicts like, okay, with the current snow height, we advise to do this and that. Yeah, so this is like the entirety of our application. And then to see more about the infrastructure and everything, you can head over to our platform, and we show you everything about it. Thank you.
Hello, everyone. Good evening. I'm Darf Abdullah, along with Nidal Karshoud. We are excited to present you our Open Data Hub project. Yep. Well, the project is a chatbot. Basically, it's a chatbot, and it helps everyday users to check the data of the Open Data Hub. It's focused on the South Tyrol tourism. Well, the challenge is if you want to access the data, you need some technical knowledge and some complex parameters with different routes, API routes, and it's not user-friendly. So our solution, it's a natural language queries, automated API interface, real-time data, and conversational responses. Our system architecture in high level. The user asks a question to the chatbot using English. it will be on our React front end. It's a web application, and we have in fast API for the backend, rack pipelines, and then it displays the results to the user. The technologies we used Python, Fast API, LangChain, ChromaDB, Olama for OpenAI, and for the front end we use React, TypeScript, and some stylings with the Tailwind CSS.
So the core features of our chatbot was to use the natural language understanding to understand the context and to get the days and the location of the time he sent his query, and using the LLM's pipelines we extract the data from the message he sent, and then we like converse it and correct it, and we get the valid parameters and modify it into queries, and then we start retrieving that query from the Chroma database to and then after that we create our query API with using the semantic search that the Chroma database provide. After that we send it to the Open Data Hub and we get the results. After that we use another LLM that will be like a real-time data fetching, and then get the information that exactly the user asks for, and we provided for the user interactive widget and Premium UI UX. We send the data using cards, and this is the highlight of what I said. We start with the retrieval. We found the relevant information from the database, the reasoning, decide the parameters for the query, and then the execution with the validation, and then with another LLM agent, we re-reason what we get and augment that data and send it again to the user in cards, in both cards and natural language. This as also an example. It's under identify the API that must be used. If the user asks for the weather, it will get an API for the weather from the Open Data Hub, which is stored in our database. If it's asked about accommodation, it will fetch it from the accommodation API, and then it calls the Open Data Hub API, and then with synthetic response generate the parameters from a JSON file, and then we receive the data and display it on widget. So this is like it's an LLM agnostic. So the quality of the response, it depends on the LLM on itself. If it's a lot of data, it can be like it can lead the program, the LLM, to hallucination, or it so depends on the LLM efficiency. And for user, it's going to be easy to use, fast and accurate with beautiful UI UX, both natural language and the card. And it can be cost effective, and it's we use the modular architecture, so it can be scalable and also competitive, and it's data-driven insights. So thank you very much.
So, yeah. Good evening, everyone. Today, I'm going to talk about our system, South Tyrol Activity Recommendations Assistant. So this system uses Open Data Hub datasets and large language model to give out useful activity recommendations for the users of South Tyrol. So let's start. So the problem that we are trying to solve here is that while planning an activity, it depends on a lot of factors like location, date, weather, and all of that. So even though weather data or events data are available, it is spread across different platforms and as different data sets. Now, also whenever a user asks a question to a chatbot or an assistant, he would want a personal suggestion rather than a raw data. So our main goal is to combine the Open Data Hub datasets along with AI to provide useful activity recommendations rather than just a raw data using a natural language. So the system overview, basically in our system, user asks a question. For example, what can I do in Bolzano tomorrow, in a really simple and natural language. and the system will then fetches the live weather data and the local events data from the Open Data Hub datasets. Now, the large language model is used to process this combined information, and then the user will get a context-aware recommendation rather than just a list of events, maybe. So coming to the technical architecture, so the front end is built using Angular and is responsible for user interaction. The back end is a .NET Web API, and it is responsible, it has all the logics and request orchestration. Also, like I mentioned, we are backend fetches the live weather data and event data, and the LLM is used to reason over this data. Also, I want to mention we haven't used a specific database where we are storing all this data, and we are fetching the live data because we want to keep our system simple and up to date as well. So our system is also designed to be extensible in a sense that we can use new data sets without actually making any changes to the core structure. And not only that, AI prompts and logics can be improved independently. So it is also generalizable because the same logic can be used for other regions as well, not just South Tyrol, but as long as the open data sets are available for them. And so advantages. So the biggest benefit of our system is that it uses the Open Data Hub, official Open Data Hub data sets, and it also provides real-time context-aware recommendations. And it's like the interaction is happening in a proper natural, it's just a natural language interaction. So some of the challenges it was a little hard, it was a little challenging for us to combine these heterogeneous data of weather and event and point of interest data, but we are good now. And also to interpret the user free text queries was the other thing, but it's all solved. And future work, we would like to improve the intent extraction and also add multilingual support because South Tyrol itself is a trilingual area, and also introduce user preferences and personalization so that the recommendation becomes more tailored. So that's it. Thank you. See you all.